All right, learning targets 2 and 3 are going to go both in this video here for Unit 3. We're going to learn how to fit a line or a linear function for a scatter plot. We're going to call that a line of best fit. And we're going to learn to interpret the slope and the intercept of that linear fit to the terms of the context of the data, or basically the variables. So let's quick get a vocab word down. Regression line, or also called the line of best fit, also called a linear model, is a line drawn through a scatter plot of two variables. The line is chosen so that it comes as close to the points as possible, and we're going to just choose our line now. Later in this unit you'll learn more about how to break up statistics and choose a line based on quartiles. But this week you get to just kind of choose. So to practice that choosing, you're going to go to this link that is in your website or in your note sheets. It's also on the website, so if you want to close out of this video and just click on the link there, or you can type that into your address bar, or this into your address bar. We're going to go here and spend about 5 minutes just kind of practicing this. So if I go here, we have a little applet, and what you can do in this applet is just put points everywhere. So from our last video, this is a scatter plot that looks like it has a pretty strong linear correlation. Okay, so what this app does is it allows us to guess what we think the line should be. So if you click on student guess, it's going to give you a line, and then you can just put that line where you think it best fits this data. So I think this line best fits the data. I'm going to go with that line. I think it's pretty good. And then, so my slope there is 0.88, and this probably doesn't really matter because you don't know what the variables are and that kind of stuff. But then you can check it with the computer line. So that if you click that box, a computer line comes up, and I was a little off. I thought about putting my line down. So why don't you go ahead and go to that link and try at least 5 different scatter plots. Make some scatter plots that go down. Make some scatter plots that have maybe no correlation, and see how you can do. And just see how you do there. You can remove some points. You can move points, and you can just reset and start over again. So you can mess around with that for about 5 minutes and then come back to the video, and we're going to practice this. So on the last video I made a scatter plot of couples' ages. Okay, and so we're going to fit a line of best fit or a linear model to this data. Alright, so I'm going to choose, what I like to do is choose 2 points that I think best represent the data. And then draw my line through those points. So I'm going to choose maybe this line, or this point and this point, to fit my line to it. Oh, but I think I want to be closer to this point. So maybe these 2 points. So I have 2 points on my line. I have this point and this point that go right through it. So if I look at that, that's 37, 36. So 37, 36, that's this point. And looks like 47, 47, this point. So I've chosen 2 points on my line, and now what I want to do is I want to make an equation for this line, or actually I want to talk about the slope, because our learning target here is to interpret the slope and the intercept of a linear fit. So we're going to take a look at this line that I've made. So I have the 2 points, and I'm going to write them over here, 37, 36, and 47, 47. Okay, so my slope here, to calculate slope, we know that we do the rise over the run, and that can be y2 minus y1 over x2 minus x1. So that's just the change in y's over the change in x's. And for those of you that don't know, triangle is a symbol for change. So yeah, we can just take this, and usually the first point, this is going to be our x1, y1, and this is going to be our x2, y2. So I'm going to take my y2 and subtract my y1, so that's going to be 47 minus 36. Now that over my x2 minus x1, so that's 47 minus 37, and then I get 11 over 10, which reduces to 1.1, which is really close to just 1, right? So that means for about every 1 year age difference in a wife is a 1 year age difference in man. It looks like, according to my line, the women for every 1.1 years difference is the change for a woman versus a 1 year change in a man. But we can look at that and say women and men are close to increasing their age 1 year at a time. For every 1 year older the man is, the woman's 1 year older as well. That doesn't mean that they're the same age. It just means the rate of change is close to 1. Okay, you can see that these couples are not the same ages by any means. They're similar in ages, but their growth is about 1 to 1, a little higher on the wife's side. And I think this point has something to do with that, because the wife grows. All these points, our husbands are older, and then this point is the only point where the wife is older. So that would be what our slope is, okay? And the y-intercept in this case, we can actually calculate out what our y-intercept would be, and I'm just going to go to a new slide here. Okay, so I know that I have these 2 points, and I have an m, or a slope of this. So right now I have an equation, y equals 1.1 x plus b, and I want to find this b. I could look at my graph and see where my line crosses y-axis, but I can't actually see that on my scatter plot, and I want an exact number here. So what we can do is we can plug in what this is going to be. So I'm going to take, and I'm going to plug in a point. So 47, 47. That means 47 is going to equal 1.1 times 47 plus b. Okay, so 47 equals 47 times 1.1 is 51.7. Okay, and then if we subtract 51.7 from both sides, we're going to get negative 4.7 equals b. So that means our equation is y equals 1.1 x plus a negative 4.7. But let's think about this negative 4.7 in terms of the context. That means this line is going to cross, if we go down to where this is 0, 0, this line is going to cross our y-axis. Actually, we're going to have to go further down. We go down to 0, 0. This line is going to continue to cross at a negative number. So that means when the husband's age is 0, the wife should be negative 4.7 years old, which obviously doesn't make sense in the real world. But what that does tell us is, on average, according to my line, how much younger the wife is than the husband, right? If the husband was 0, the wife should be 4.7 years younger than him. So we can say, according to my line, and not necessarily all the data, but according to my line, that's where we would end up. Okay? All right, so then that's the real world scenario. Obviously for this, that doesn't make sense, and you wouldn't have anyone at age 0, any babies getting married, so that doesn't make a lot of sense in the real world, but it does tell us a little bit mathematically, and we can still relate it to our variables, and that's going to be one of the skills that we're going to work on as a class and that you're going to practice and be assessed over. So for class, you are asked to create a scatter plot from the data below, and then choose a line of best fit and write an equation for your line, and then talk about how does the slope and the y-intercept of your line relate to the number of people and the cost. And we don't really know what this table is referring to, but we can make some assumptions about the rate of change versus people and cost, and then what that y-intercept means in terms of the two variables as well. So go ahead and try that for class.